Okay, and we're ready to go. So last time we were still in the preliminaries, and we're going to still spend some time there because it's very important. So last time we were talking about a general approach to factoring. We're going to finish up that discussion. Factoring is super important. We need to simplify stuff. We need to help us solve equations, etc. So you should know how to factor things in general. And there was a multi-step process which you kind of go through things somewhat in this order. The first thing you want to look for is if there's a GCF, a greatest common factor. First thing you want to do is factor that up. So you're always looking for that first. Okay? Is there a term that's in every one at the same time? You factor out the lowest power. We also talked about how do you know what you leave over inside the brackets? Well, you subtract the power of the thing that you pulled out, and so that's how you figure out what powers are left inside. The second, you might see something with two terms. So if there are two terms, you need to think of things like difference of squares. Or sum or difference of cubes. These are very common expressions to show up on an exam, so you should notice them whenever they show up. And we looked at the formulas for those and applied those. The third one, if there are three terms. Well, you could see if it's a perfect square, but honestly, if you do one of these other two methods, it's going to work. And we didn't get to talk about these, we're going to talk about them today. There is trial and error. And I don't know what the actual name of the method is, but to me it's trial and error. And then there's the AC method, which is kind of a structured trial and error. So it's still a little bit of trial and error there, but it's easier to structure it. So then there's also the case if there are four or more terms. That's where you're going to try factor by group. There are other methods that you can use to factor things in general, but those cases will not show up in our class. So there are things when you have to do like the rational roots theorem and use long division, we're never going to get there. So one of these methods should work, and the fifth one is see if any created factors can be factored further. So sometimes you factor something, and the thing that's left over, you could actually factor it again. There's definitely a problem like that on the first quiz. I don't remember if I put one like that on the second quiz, but you can definitely see that. So you always double check. After you apply one of these rules, look at all the factors that you have left over. One of them might be able to factor even further. So we covered this, and we kind of started talking about that, but let's actually continue talking about that. Make sure that we're all on the same page when it comes to this. So we have some examples here in the sheet that we're working through. Chapter 0, and we are on the 4th page. So basically we want to factor, so let's talk about step 3 more. We want to factor things like, that look like ax squared plus bx plus c. Okay, so you have an expression like that and you want to be able to factor it. There are a couple of ways. Now if your a is equal to 1, then what you need to do is you need to find two numbers. That multiply to give c, and sum to give, right? So just that. And say these are R1 and R2, then your x squared plus bx plus c would factor into x plus R1 times x plus R2. So people are usually familiar with that, but let me just go through an example to make sure we're all familiar with it. So if we look at the example A here, we have x squared plus 5x plus 6. So notice here that your A is 1 specifically, right? There's nothing in front of the x squared, which means there's a 1 there. And so now you want to think of how to factor this. Right? So whenever you see that, you kind of assume it'll factor. It doesn't always, but you start to open up parentheses like this. And then you put in your x's, because x times x is what's going to give you that x squared, so the coefficient of both of these must also be 1. And then you try to come up with two numbers that when you multiply them you get 6, when you add them you get 5. 3 and 2. That one's especially easy. Let me throw a slight modification here on this. So let's again put a plus 6. I change the middle sign. Can that still be factored?
Yeah.
What is it?
Negative 5, negative 1.
6 and 1.
Negative
It's not
6
factored.
and
Positive
1.
It's not factored.
Huh?
Negative 6, positive 1.
Well, if you throw negative 6, positive 1, what's going to happen when you multiply those?
It'll be negative 6.
You get a negative 6.
So it won't be.
Negative 3 and
Negative 2.
Negative
right.
3 and negative 2 would work. What if I had x squared minus x minus 6? Does that factor?
X minus 3, x
X
plus
minus-
2.
Multiply minus 3 by positive 2, you get negative 6. Minus 3 plus positive 2 gives you negative 1, etc. That's the idea. So just by changing out the middle sign, changing these numbers, you can have differences. But if something like this, you can't really think of two numbers to get that, and you need to make sure that there are no such numbers, you'd have to try something else to deal with that case. Maybe it doesn't factor nicely, or you'd have to use a quadratic formula or something like that. But this is one of the easy cases you'll see, and surely whenever one of them shows up, you should be able to get through that problem relatively quickly. So that's usually when your A is equal to 1. Now what if your A is not equal to 1? Now here there are a couple methods. There's the trial and error, and then there's the AC method, and we have an example here. So we're going to do both ways on this guy. Then we're going to talk about, recommendations and all that stuff. So let's say we had that. So clearly here your A is not 1. Two main ways to deal with this. Trial and error. Or 2, AC method. Let's do trial and error first. So here, you are going to start opening up parentheses just like here, but you're going to have to be a little bit more sophisticated with the guessing game. Okay? So now, you need to come up with expressions in the front. You're kind of reversing FOIL, so you have the first, outer, inner, last. So you know the first number actually comes from the multiplication of the two first numbers. So now you want to think, what are the two things I should multiply to be able to get 2x squared, right? 2x and 1x would be obvious candidates here, which it's not always obvious right away, right? Sometimes this number could be, for example, 6. then you have options to try maybe 6 and 1, maybe 3 and 2, right? So it can get a little bit more complicated, but let's start out easy here. There's only one way to get 2x squared with multiplication of integers. It has to be 2 times 1. And so you put 2x and 1x in that one. Now, the next thing you're going to do is you're going to try to put in numbers at the ends that multiply and give you 2, right? So you're going to want to put numbers in here multiply to give 2. Now, there is one thing that makes it a little bit more complicated in this case whenever a is not 1. The summing requirement is a little bit more complicated. You also want the numbers to behave in the following way. The product of the outer ones, so if you take the product here, plus the product of the inner ones, those must add up to the middle term. So you want two numbers that multiply to give you that 2, but in addition to that, you need to make sure when you multiply the outer numbers and the inner numbers and add those expressions together, you get the middle term. So here you have a couple options. Let's actually do the wrong one first so you can see when a wrong thing happens. So let's say you say, well, to get 2, again, there are only 2 options, 2 and 1. So let's put a 2 here and a 1 here, right? Then what's going to happen? Well, now if I multiply the outsides, I would get 2x. If I multiply the insides, I would get 2x. And now I ask myself, could I use 2x and 2x to get to a 5x? The answer would be no. So it means that those were the wrong choices or the wrong order. Now, if I decide to, okay, it might not be the wrong choice because really to get 2, you only have the option 2 and 1. Maybe I should put the 2 here and the 1 here. And now you can check those two products. Right? Multiplication of these give you what? That's 4x. These gives you 1x. So now you have to say, can I use 4x and 1x to get 5x? And the answer is yes, just make both of them positive. And that's the factor. Okay. There are a couple other ways you could know. This is kind of a pro tip, like when you start to become more of an expert here. But there are a couple other things that would hint to you that where the 2 and the 1 should have gone. Because let's say you put the 2 here and the 1 here. What does it say to you, the fact that there's a 2 here and a 2 here? It means you could have factored out the 2, which means you could have gotten something that looks like this. However, if you could have gotten something that looks like that, 2 would have to be a common factor at the very beginning. You cannot divide 2 evenly into 5, so this situation is impossible. So you wouldn't even think of putting the 2 here because you're creating a common factor that you know isn't there, right? So when you get more practice, you'll start to see these little tricks. But in the beginning, it's just okay to just do some trial and error, switch them. And this is the method I prefer by far because it'll take a little bit of a while to actually get really good at it. But once you're good at it, you'll do it a lot quicker than the AC method. The AC method takes out a little bit of the guesswork, but you kind of have to also come up with numbers that do certain things like that. So that's kind of the trial and error. So try to figure out 2 numbers. Maybe I don't think I gave another example, but maybe I should make up another example just for you guys to try it out, and then we will do the AC method on the first example. Don't look. Try this one.
Is the AC method the diamond method? Is that the same thing, or is it?
I don't know. We're going to do it after this, so you'll see what I'm talking about when I refer to the AC method. Try this one. 6x squared minus 5x minus 6. So you're going to break it into these two parentheses. Now this is immediately a little bit more complicated because now for the 6, you can have 6 and 1 or you can have 3 and 2. Right? So you might even start by thinking, okay, what if I put 6x and 1x? What's going to happen now? What are some candidates for here? So now there's also 3 and 2. What would you try here?
Positive 1, negative 6.
So don't worry about the signs yet, right? I would worry about the signs until after you check the problem. But let's say you put 1 and 6, what would happen? That would give you 36 and 1, right? Clearly nowhere close. What if I put the 6 and the 1? Well, putting a 6 here creates a common factor, so that can't be right. So 6 and 1 won't work here. What about 3 and 2? 3, 6 is 18, and then 2 can't get to 5. What about 2 and 3? 3 and 2. Then I'd get 12 and 3, can't get to 5. So it turns out that 6x and x wasn't the right choice here because I have exhausted all options. So it should be the 3 and the 2. And so now I start to play that same game again. Maybe a 1 and a 6, well that would give me 18 and 2, can't get to 5. Maybe a 6 and a 1. Then I would have 3 and 12, can't get to 5. Maybe a 3 and a 2, well putting a 3 here creates a common factor, that can't be it. So maybe the 3 should go here and the 2 should go here. Now you would have 9 and 4. Here's 4x, here's 9x. Could I use that to get to a 5x?
Yeah.
Negative 5x. So what would the signs have to be now?
Positive.
I need a negative on the 9 and a positive on the 4, which tells me a plus should be here and a minus should be there. And so ultimately, that's the factor here. Now I deliberately started with the wrong numbers in place so that you can tell when you're wrong. That's important as well. But in general, once you really get used to this method, you'll start to be able to pick the right numbers right away. And you'll start to realize things like, well, if the middle term is super close to the near and the far terms, then you don't want to break the first number into very big gaps, right? The gap between 6 and 1 is a lot bigger than the gap between 3 and 2. And so you probably wouldn't guess the 6 and the 1, etc. Okay. So personally, I'd invest the time to learn this method if you haven't learned it, but it's completely up to you. You have the option to do whatever you want as long as it's correct and valid. So let's look at the AC method. So now the AC method includes factoring by grouping, which we didn't talk about, but I guess maybe we can talk about it while we're talking about this. So the AC method says the following. Remember, we want to factor ax squared plus bx plus c, right? So the AC in the AC method refers to these two numbers. So the method says 1 multiply a and c. 2. Now we're going to do kind of like the first method, except we want this term in the end. So we would say find two numbers. That multiply to give AC, but sum to give middle term. Once you find those two numbers, you are going to break up your middle term into these two numbers. Then, finally, to complete the problem, you would factor by grouping. So we're going to talk about what that is. That's another technique, that's in another step. But by doing that method, you can factor a quadratic as well. This is called the AC method, because you start by multiplying A to C. So let's go with this example again. So 2, let's try the AC method. So what you do here is you first find AC. What is AC in this case?
4.
It's going to be 4. Now you want to figure out how to find two numbers that when I multiply them I get 4, when I add them I get positive 5. What are the numbers? Plus 4 and plus 1. Now what you're going to do is you're going to break the middle term into those two numbers. So that 5x you're going to think of now as 4x plus 1x. Emphasize that. 4x plus 1x, right? From here and from here. So you're going to break up the middle term into those two numbers. Now what, and by the way, it turns out here, the order does not matter. So that's not something you have to worry about. If I had put the 1 here and the 4 here, it's still going to work out. So you don't have to worry about that. The order you put them in does not matter. So I find the AC, think of two numbers that when I multiply I get the AC, and when I add them I get the middle term. Then you're going to break the middle term into those two numbers. Then you're going to do factor by grouping. Now how factor by grouping works is that you group things together, usually in equal quantities. So in the case of there are 4 things, you would group 2 and 2. Now when you group the 2 and 2, you start by factoring out the GCF. You want the general common factor. So among the first two, what is the general common factor?
2x.
2x. 2x is what's common to those guys. So you're going to factor that out. I would have left.
X plus 2.
I would have left x plus 2. You move on to the second one and you do the same thing. What's the general common factor?
1.
It's just 1. X plus
X
2.
plus
So now, once you're applying factor by grouping properly, or factor by grouping should work, you should notice that the thing left over in parentheses should be the same. Otherwise, you made a mistake, or it's a case where factor by grouping just doesn't work. Same thing should be left over. Now that the same thing is left over in parentheses, you would have noticed what you did was you created another common factor. Now the factor x plus 2 is in both terms, which means you can factor it out. Right? So now we're in the case where we have 2x times x plus 2 plus x plus 2. This is a common factor, so I can factor out the x plus 2. And then I write out what I have left over on the inside. Well, that's 2x plus 1. And that's your factor. This is called the AC method. A little bit less trial and error. You'd have to write out all your steps, but this is a method that works, and it's more than valid for you to use it. So you find AC, multiply the first and the last number, figure out a number that when you multiply you can get that, but you add to get the middle term, break up the middle term, factor by grouping. Factor common things from the first two and the last two. You should have the same thing left over. That's a common factor that you can now factor out, and then you'll be left over with the factors here. Another quick example. What was the guy I put up here? It was 6x squared minus 5x minus 6. Was that it?
Yeah.
Okay. So, so with the AC here would be minus 36. The signs are important. Two numbers that when you multiply you get minus 36, but when you add them you get minus 5. Negative 9 and
4.
so 9 4 is 36, making it a negative 9 and a positive 4 would give you a negative 5. And so what you do is this now becomes 6x squared minus 9x plus 4x minus 6. Now we'd factor by grouping, common term in the first two. 3x is a common term, I'd be left over with 2x minus 3. Common term in the second two, 2. I would be left over with 2x minus 3. Now notice that 2x minus 3 is a common term, I can factor that out. And that's the factor. And so now, step 4 was factor by grouping. But we covered this just now. That was the whole factor by grouping thing. Factor by grouping is what you do at this point. This method here is called factor by grouping. Right? So you group things together, factor out their GCF in such a way that what you have left over is going to be the same thing. So you'll have to have an even number of things. So if you have 4 terms or 6 terms or 8 terms, etc., you can do this method. And hopefully you will get the same thing left over in the parentheses. And in general, again, remember the order in which you put these do not matter. I could even show you that here. If someone else had put the plus 4 here and the minus 9 here, the common factor in the first two would now be what?
2x.
You'd be left over with? Common factor here
3.
would be minus 3. And you'd have 3x plus 2. Now, if 3x plus 2 is a common term, you can factor that out. You'd be left over with 2x minus 3, right? So you get the same thing. You just get it in the other order, but multiplication of the order doesn't matter. Okay. And then there are cases where sometimes you go through a method and then one of these guys that's left over you can factor even further. Then you pretty much just go through the method again to factor that guy. See if it's a difference of squares or a difference of cubes, see if you have to do something like the AC method or factor by grouping, etc. So factoring is super important. You need to be super good at it. Just doing a little crash course here, but you should attempt a lot more problems if factoring is a problem for you. Now let's talk about solving equations. That is also going to be super important. How do you actually solve an equation? What does it mean to solve an equation? So, you know that a linear equation, this is a bit of a misnomer, but whatever. A linear equation is one that's of the form ax plus b equals c, where your a is not 0, but your a, b, and c are constants. Quadratic equation is one that looks like ax squared plus bx plus c equals 0. Again, it is not 0, a, b, c constants. To solve an equation means find the x values that make the equation a true statement. So, in other words, and these x values are called solutions of the equation. The set of all such x values, there might be more than one, are called the solution set. You'll find out usually mathematicians aren't very creative when naming something. So they're like, what do we call the set of solutions? Solution set? Seems to work. This theorem seems very fundamental to the study of calculus. What should we call it? Fundamental theorem of calculus. It's like that's the name of the theorem. So, yeah. So, okay. So those are the two kinds of equations. Very important for us to be able to solve these. Let's talk about the property that we all know, or should all know. Okay. Now Now the last one, every now and then I see students get it very wrong, but the first few, we should all kind of be familiar with, but let's make sure we know properties of equations. Okay. So here is the idea. Let A, B, C be expressions. I told you what expressions were last time. Here's the first property of an equation. If A equals B, then A plus C will equal to B plus C. In other words, you can add the same thing to both sides of an equation and not change the solution set. That's where the adding to both sides come from. If A times C equals B times C, and C is not equal to 0, then A is equal to B. i.e., multiplying or dividing both sides by something. Multiplying and dividing both sides by a non-zero number does not affect the solutions. This is called, this by the way is referred to as the Cancellation Law. It's a very nice law. Not all number systems obey it, but the real number systems it does. So this is the law that says you can cancel something from both sides. If things are being multiplied, you can sort of divide both sides by C and cancel. 3. There was a fourth one. What order did I do that in? Just to be consistent with my notes. Oh, at 2 and 3 I sort of combined. I put multiply. I had split up an example with multiplication and division. So that's 2 and 3. 4 is another important one. This says if A times B equals 0, then either A equals 0 or B equals 0. This is called the zero factor property. Again, it's a peculiarity of the real numbers. Not all number systems would work this way, but the real numbers do. So the idea is if a product of two things is equal to 0, means one thing or the other thing must be 0. It's important. And let me explain here. Must be 0. It does not work with any other number. There are times when I put things on like tests, like I would say something like, okay, solve for x. X minus 2 is equal to x plus 3 is equal to 7. And then what they do is they set this equal to 7 and that. You can't do that. It has to be 0. This does not apply unless there's a 0 on the right side, right? So you can't apply here. So if you see something like that, what you need to do, you need to expand the parentheses, bring the 7 over, refactor, and get it to be a 0 on the right side and a multiplication on the left. It will only work if there's a 0. It does not work in any other situation. Yes?
How factoring? Like,
Factoring what?
the fractions?
The fractions?
Yeah, with the line between like this number. There's a numerator and a denominator. If we can make the numerator be 0, can it be also equals to 0?
Yes, that also applies here. The A and B can be anything. They could be fractions, they could be whatever. This is just a general thing. If you have one thing multiplied by another thing, doesn't matter what they are, if they're fractions or whatever, once it's equal to 0, one or the other must be 0. Yes, and if one of the things is a fraction, the only way a fraction can be 0 is if the numerator is 0. But these are general expressions. They can pretty much look any way they want. This will work in general. So now, the goal of solving an equation, as I said, is finding the x values for which the equation is a true statement. And what those properties I just gave you do, they don't change what the solution is. They simply put the equation in a form that's more convenient for you to tell what the solution is. Okay? So that you should know. So let's talk about solving linear equations now specifically. What I just said verbally is in your notes, so I'm not going to write it down. To remember what I typed. Okay, solving linear equations. So basically, the idea is figure out what x values is going to make that statement true, and we can do any of these manipulations at any given time to be able to coax our equations into looking a certain way so that we can tell what the solution is. So we're going to go through these. We're going to do this one in two ways. Choose whichever one you prefer. We'll also do this one in two ways, and you can choose whichever one you prefer. I'll tell you my preference, but I'm kind of a weirdo sometimes. So. Why would you do it that way? I'm also a futurist, so sometimes if I know, for example, like a lot of you would have to go to Calc 1 after this, I'm not only going to tell you a method that's good here, but I'll also tell you a method that will be good for you in the next class. So yeah, it'll be a little bit easier to do this here, but if you learn it this way, it's going to be with you for the next 5 years. So I think it's worth the extra effort. Because sometimes the simplest methods aren't always the best ones for all cases. Okay, so let's go through these very quickly. What do we do here?
-1.
Subtract 5? Or why would you do that?
-1, you could divide by 2 after the next one.
Okay, so again, let's remember the goal. Technically, we could subtract 5 from both sides and we could subtract 1 from both sides. That would be fine in either case. One thing is less efficient than the other. So let's just remember, the goal is to obtain a statement like x equals something, right? In other words, you want the x to be isolated on one side of the equal sign. Isolated on one side of the equal sign. So that will keep you somewhat more efficient when you understand that's my goal. My goal is to get the x by itself. I want to be able to say x is this thing, right? Because that's what solving an equation means. Now, if your goal is to isolate the x, which you can see is right here, would it be more efficient to subtract 5 from both sides or subtract 1 from both sides? Subtract the 1, because you're getting rid of something that's on the side that has the x. You want to isolate the x, so you tend to want to get rid of things beside it. So subtracting 1 from both sides, which is valid by property 1, is probably the best thing to do at this point. So once you do that, you would get 2x equals 4. Now you can do properties 2 or 3, whichever way you want to think about it. It's multiplication, division, kind of the same thing. Except with the division by 0 case. But yeah, so now we can divide both sides by 2, or you can think about it multiplying both sides by a half. Those are equivalent operations. So you can now divide both sides by 2, which we're allowed to do by properties 2 and 3. And so this will give us that x equals 2. And you can see if our x is 2, this statement would say 2 times 2, which is 4, plus 1 is 5, and that is a true statement, which means we have found the solution. X being this value makes that statement true. So at any given time, if I solve for something here, let's say I got x equals 3. Go back here, 2 times 3 is 6, plus 1 is 7. Nope, that is not the solution. It does not make this statement true. Okay, first step.
You would do plus 2x to the other side and minus 5 on the other side.
Right, so I would add 2x to both sides to get the x's on this side, knowing that I want to isolate the x. That 5 is going to be in the way, so I'd at the same time subtract 5 from both sides. Ultimately, I would obtain 5x and 15. This puts me in a situation where I can apply rules 2 or 3, and so then x would be 3. C. 3 over 4, x minus a half equals 2/3. My preferred way is to clear the denominators by multiplying through by the LCD. Right, so remember we spoke about LCD a little bit, I think, in depth. But what is the LCD of the denominators here?
12.
It will be 12. So the first thing I would do is I would multiply both sides of this equation by 12. So now 12 times this, the 4's would cancel and I'd get what? 9x. 12 times a half, the 2 goes in that would just give you 6. This, the 3 cancels, you're left with 4, so that's 8. So in a situation where you have no fractions, it's much easier. And then, so you'd have 9x, you'd add 6 to both sides, you get 14. And so x would be 14 over 9. Or, you could do what we had before and just add the half to both sides. You get 3 over 4x is equal to 2/3 plus a half. But now you'd have to add those fractions. It's going to be 4 plus 3 over 6. 4x. And so now you can apply the rules 2 or 3, multiply by 4 over 3, multiply by 4 over 3. And so this would be x. So this will give you, well, 2 into this goes 3 times, 2 into that goes 2 times. you end up with 14 over 9. But that little step of adding the fractions sometimes messes people up. So I'd rather just multiply through by a number to kill all the fractions, and then you can add them. Par recommended. Multiply by smallest power of 10, that kills the decimals. Jeez, I'm writing kill it right in. Jeez, this day and age, kills the decimals. Specifically, you want to multiply by 10 raised to the n, where n equals the most number of decimal places. It's not grammatically correct, but I don't care. Largest number of decimal places. Right? So if you see a bunch of things, some of them have 2 decimal places, some of them have 3, some of them have 1, you multiply by 10 to the 3. So in this case, everyone has 1 decimal place, so I'd multiply by 10 to the 1. So for the original equation, I'll just multiply it all by 10. And what that does is it moves the decimal place 1 place to the right. Right? It will move the decimal place by the power of 10 to the right when you multiply by 10. You divide by 10, moves it to the left. Okay, so here, this now would become 4x plus 6 equals 12. You can subtract 6 from both sides. And then divide both sides by 4, so your x is 32. Or you could just go through and start adding with the decimals. So this would be 1.2 plus 0.6 would be 1.8. And so this would mean that your x would be equal to 1.8 divided by 0.4. But how would you deal with that?
You multiply the numerator and the denominator by 10.
Great.
18/4.
So you can,
Why are you adding 6?
oh, no, subtracting 6. So minus. So subtracted 6, so now we'd have 0.6. And so now x equals 0.6 over 0.4, which at this point you'd multiply both by 10, so that gives you again 6 over 4, which is the derivative. What about e?
We distribute.
Distribute first, because of PEMDAS. And because you know you want to isolate the x, and the x here is stuck in parentheses, so you kind of want to break him out so you can isolate him. This is be minus 6x minus 2 equals 21.
And then you put 5 minus 2. It's just 3. Combine that.
Yeah, you can combine like terms, so you have minus 6 plus 3 equals 21.
And then subtract 3.
Subtract 3,
And then divide it by negative 6. Whatever.
so that's 18, and so your x is 18 over negative 6. That's what, minus 3?
Yeah.
So that's solving linear equations. They're not very bad. Just think about isolating the x. And you'll be fine. Let's talk a little bit about solving nonlinear. especially with x in several locations in unlike terms. So you can also be required to solve things that are just not linear, not necessarily quadratic, but not linear. And in general, there's a method that works nicely with these. So the strategy for solving any such thing would be to bring everyone to one side, bring all terms to one side, so that the other is 0. Let's say left, just because, just be different. Factor left side. And apply the 0 factor property. Do a couple examples here. X squared minus 6 equals minus x, and x cubed plus 3x squared minus x minus 2 equals 0. So that's A and B. A. So according to this strategy, solving things nonlinear, and this happens to be a quadratic, which we'll deal with specifically, but it's not linear because your x has one of the x's has a square in it. X's are all over the place. The first thing you want to do is bring all x's to one side. And not just bring all x's to one side, but bring all terms to one side. So that one side is 0. Now what you want to do is you want to factor. Now how do we factor that?
2 and 3.
We'll try to undo a FOIL here. 3 and 2, what are the signs? Plus 3 minus 2. So now I have some expression where I have two things multiplying giving me 0. This means according to the 0 factor property, one must be 0 or the other must be 0. So this means that your x must be, now this is linear, you know how to do that. X is minus 3 and x is minus 2, that's your solution. And you can check that both of those would work in the original. If you look at B, that already has 0 on one side, so your goal would be to factor the left side. How do you factor something like that?
By grouping.
Factor by grouping, right? This is step 4 in the factoring process, right? You just kind of skip over all the, well, you still always try to look for step 1. Is there a greatest common factor? The answer is no. Obviously it doesn't have 2 terms, so it's not difference of squares or difference of cubes. Obviously it doesn't have 3 terms, so it's not AC method or trial and error. This has 4 terms, and one step says think factor by grouping. So I would group terms together and try to factor out the common factors. The common factor here is x squared. The common factor here is just a minus 1. Now I've created a common factor of x plus 2. I can factor that out. And now I have that expression. Step 5 also applies here because it turns out after doing my factoring rule, I end up with something that can be factored further. This you should recognize that this is the difference of squares. So now the 0 factor property takes effect, and that means your x plus 2 equals 0, or your x minus 1 equals 0, or your x plus 1 equals 0. And so this means that your x is minus 2, or your x is 1, or your x is minus 1. That's the solution. So this is kind of an approach for general things. If you have any equation, then no matter how weird it looks, one thing you can always do, bring everyone to one side, try to factor it, and apply the 0 factor property. solving quadratic equations. Three main ways. One, the above. Use zero factor property. As used above. One way to solve a quadratic. Two, another way is to what we call complete the square. I will show you this. It's not a very popular way to solve a quadratic, but I'm going to show you because eventually we'll talk about circles where completing the square is going to be important for dealing with circles. However, you can use completing the square to prove a very nice formula that will work with any quadratic called the quadratic formula. So these are three main ways you can do that. So just look at some examples. So usually you'll stick to this or that, and I'd recommend you try this first and try this second if one does not work. That would be the recommendation. I'm going to show you this, like I said, because it'll be important for the future later. But typically, if in a random problem, if you're solving it, very few people would opt for completing the square. But it's something that you should know how to do. Example. Those. So A, let's look at that one. X squared plus 5x plus 6. Try to do method one. How would we do the zero factor property? Right, you get to factor that. So you have x plus 2, x plus 3. So your x equals minus 2, or your x equals minus 3. That's basically it. How would you solve that one?
With both sides?
Bring everything to one side. Let me mention here a very common mistake. Is that some people would have the urge to divide by x. So they'd have a 5x squared equals 20x, and they're like, I can just divide both sides by x. And so they'd have a 5x equals 20, and then they'd get an x equals 4. And that would not be the right answer. Why? Because for one, you should notice that x equals 0 solves this equation, so dividing by x or potentially dividing by 0. And two, you actually miss the solution when you do that. So don't think of dividing by a variable or anything like that. Follow the method as described before. If you have several terms, bring everything to one side. Don't start dividing and multiplying. Bring everything to one side and factor that side. Because once you start dividing by variables, you're probably going to do something illegal or you're going to miss some answers. So the right thing to do is to divide, is to move things to one side. Factor this. How would you factor that? 5x is a common term, so it's step 1, GCF factor. So this leaves us with x minus 4. And so by the zero factor property, this will give us x equals 0 or x equals 4. So there are two solutions to this one. How do we do this?
to the terms and then 13, no, minus
Okay.
13.
Right. Again, common mistake is to set this equal to 13 or that equal to 13. That is wrong. You cannot apply the zero factor property unless there is a zero. So what you would do instead is you'd actually FOIL. That would give you this. Bring the 13 over. And that would give you what? Huh? Come again?
Is it 5?
7.
Okay. Now what? How do you do with that? So you might start to do this, right? And so you put x here, and so now to get the minus 7, you can have 7 and 1, right? That's pretty much the only options. But in either case here, 7 and 1 is not going to get you to 5. So now it's like, oh, what do I do now? So the factoring rule seems to not work for you too much here. What you do instead is one of the other methods. So now our previous factoring strategy is not working. So options now becomes one of the other two. You can either complete the square or use quadratic form. Probably let's talk about quadratic form first. So this says the solution to ax squared plus bx plus c equals 0 is given by x equals minus b plus minus the square root b squared minus 4ac all over 2a. This would mean if we have x squared plus 5x minus 7 equals 0, then our x would have to be, the a is 1, the b is plus 5, the c is minus 7. So it's minus b plus or minus the square root b squared, let's just write that down, minus 4 times a times c all over 2 times a. So this is going to be minus 5 plus or minus. That would be 25 plus 28, which would give you what, 53 over 2. So that would be your answer there. Option 2, complete the square root. So we ended up with x squared plus 5x minus 7 equals 0. So here's how completing the square works. If your a equals 1, you would do something different than, slightly different if your than if your x is not, a is not 1. But if your a is equal to 1, then you do the following. You decide the middle term. subtract 1/2 of the middle term squared. So here I would have x squared plus 5x, and what I'm going to do here is I'm going to add and subtract half the notes. So I'm going to add something squared, subtract something squared. I'm going to have that minus 7 equals 0. So you add and subtract, what you add and subtract is going to be half the middle term. So you take 5 over 2, 5 over 2. You add and subtract that. Now it turns out that the first 3 terms will be a complete square. So you know that's going to factor into a complete square. So that is going to look like these 3 here. Now become a complete square. It's going to be x plus the guy on the inside of those parentheses, all squared. And then now you kind of just deal with everyone else. So this will be minus 25 over 4 minus 7 equals 0. Now the goal now here is to isolate the x. This means I'm going to have the x plus the 5 over 2 all squared, move everyone else to the other side, so this is going to be 7 plus 25 over 4. What is that, by the way? 7, well, you can multiply by 4 over 4, so that's 28 over 4. That becomes 53 over 4. And now you take the square root of both sides, so you get a plus or minus. Then you add or subtract the minus the 5 over 2 both sides. So you get minus 5 over 2 plus or minus the square root of 53 over 4. Which by laws of exponents you can apply the radical to the top and the bottom, and you get that which we have before. So this method is called completing the square. If your a is not equal to 1, you need to factor it out and do the above method inside the parentheses. And then you can expand the parentheses to isolate the x. We'll do more examples of that when we talk about circles, so I'm not going to do anything there now. Let's bring this to example D. So we have x squared plus 8x plus 1 equals 0. The first thing you try is to do that. So you know this has to be x and x. To get 1, that has to be 1 and 1. Can't work. So now you try quadratic formula. X would be minus b plus or minus the square root of b squared minus 4 times a times c to a. Can 60 be simplified? Why can you factor 60 into? Where one of them is a perfect square. You can do this as 4 times 15. You can apply the radical to the 4 and leave the 15. So this would be minus 8 plus or minus 2 radical 15 all over 2. So this you can think of as minus 4 plus or minus radical 15, which which chances are on your exam, that's the form that the answer is going to be in, as opposed to this one. So you should know how to get from it. Okay. Hopefully that reminds you of how to solve quadratics. We have one other thing, we have to solve inequalities. Being able to solve inequalities is going to be important on questions where you need to, for example, identify the domain of a function, which is often going to be important. So these are statements in inequality. Inequality. They're statements, mathematical statements involving greater than or equal to, less than or equal to. To solve these, first treat the above as if they were equal signs. Except for two caveats. One. So that's kind of step one. If you multiply or divide by a negative, you must turn the sign the other way. So for example, if you had x is less than y and you decide to multiply both sides by a negative sign, you have to turn that sign the other way. It's no longer correct to keep that sign the same way. Other than that, you treat it as equations, but there are some times where you have to flip the sign. That's one case in which you have to flip the sign. The second case where you have to flip the sign is if taking reciprocals. And both sides are on the same side of 0. You need to flip the signs. For example, if I know that 3 is greater than 2, if I decide to take the reciprocal of both sides, this would have to turn around. Right? And that actually works because I know they're on the same side of 0. They're both actually greater than 0. If I had, for example, 3 is greater than minus 2, then even if I take the reciprocal, of course it's going to stay the same. Because the 3 is on the right side of 0, while the 2 is on the left side of 0. But as long as they're both on the same side, they're both greater than or equal to 0, or they're both less than or equal to 0, taking reciprocals flips the sign. Other than that, the first case is to treat the inequalities just as if they're an equal sign.
Wait, so you don't flip the sign?
No, you would not flip the sign here, because a negative is always going to be less than a positive. Label these by Roman numerals here, so you don't mix up what I'm talking about with 1 and 2. 2, best way I think is to draw a number line. plot the solutions, test the intervals to see which works. That's basically it. First treat it like an equal sign and just do whatever manipulations you can apply any of the properties that we did with equal signs. There are two caveats. If you multiply or divide by a negative, you have to turn the sign around. And if you take reciprocals of two things that are both positive or two things that are both negative, you have to turn the sign around. Once you have done that and you pretend it's an equation and you actually solve it, now you need to actually test the intervals to make sure that they actually, your solutions are working. So let's do some examples here. So x plus 1 is less than 3. X minus 1 is less than 2. A. So again, just pretend it's going to be an equal sign. I can subtract 1 from both sides because I want to isolate the x. I can divide both sides by 2. Since I divided by a positive number, it stays the same. This one is pretty straightforward. You don't really have to worry about it. That's actually your answer. But notice that here you cannot be equal to 1, but you have to be less than 1. We'll see a situation where testing the intervals is very important, but this one is pretty straightforward. It's not always clear when it is though. So if you look at B, how do you deal with something in an absolute value if it's less than something? You guys remember? Remember, if absolute value of x is less than some number k, what does that actually mean? K is greater than 0. It means that your x is between positive k and negative k. That's what it means. We'll talk about the absolute value itself in detail later, but as an inequality, you should know that's how they would behave. And so, if you hear if I have x minus 1 less than 2, this would mean that x minus 1 is strictly between negative 2 and positive 2. And it turns out you can kind of solve both at the same time, so you can add 1 in all locations. And you would end up with that. Which again, this is pretty straightforward, that's the answer. You can draw this on a number line as minus 1 and 3, circle, circle. You have to be in between these. I told you guys about interval notation. Did I remind you guys about interval notation? This goes all the way down to negative infinity. Open circle means you can actually write this as a parentheses and a 1. This is called interval notation. So being 1 or less, you can think of this as 1 is the maximum on the right, and you can go all the way down to negative infinity on the left. If you cannot be equal to something, you use a parenthesis. Similarly here, you could have written this as -1, 3, parenthesis, and that's the interval notation for the answer. So then the third one. This one is a little bit more interesting. So remember what we do, pretend it's an equal sign, so I'm going to bring everyone to one side and try the zero factor property. I would factor this. And that'll be +3 and -2, looks like. So now you get x equals -3 or x equals 2. But it's hard to know which way the inequality sign should turn for each. So what you do is now we do what's done step 2. When you have several x's like from a factor here and you're not sure, there are a couple ways to do it. I'll actually show you another way. You plot them on a number line. So you know 3 and 2 are the possibilities. You also know that you can be equal to them. How you would do that is with a shaded circle. But now you don't know if it should be in the middle or on the ends or wherever. So what you can do is you can actually test points. We call this testing the interval. So that's what I mean by testing the interval. It means you pick a random number in each section. It does not matter which number you pick, just pick one that's nice, so that you can do calculations easily with. And what you're going to do is you're going to plug that number into the inequality and see if it actually makes sense. So if I put a -4 here, that will give me a negative number in the first one, and also a negative number in the second one. So overall that's a positive number, which is greater than 0, so that's good. If I plug a 0 in here, I would end up with a positive number in the first parenthesis, I would end up with a negative number in the second parenthesis, which means there will be a negative number here, which is not greater than 0, so that's bad. Plugging 3 here, I would get a positive number in the first, I would again get a positive in the second, it's a positive. So it means, therefore, that this is bad, does not work, this works, and this works. And so your answer is going to be given by the endpoints. That entire region is going to be a solution, as well as that entire region is going to be a solution. And so you know, now you know how the answer should be written. So your answer is, your x should be less than or equal to -3, and at the same time it should be greater than or equal to 2. Now you know how they would turn. As in interval notation, you would write the following. This region here is from -3 going all the way down to -infinity. But you can include -3, you write that in interval notation by using a square bracket. Or, this is the union symbol. So you can either be over here or over there and it's fine. Or, in this case, you can go from 2 to infinity. Infinity is never included because it's not a number, but the 2 is shaded, so that can be included. So again, I use a square bracket. And that would be how we express that answer in interval notation. Any questions on this? Yes.
Is it x cannot be equals to -3?
No, because we had a greater than or equal sign here. So we can be equal to it.
So if there is not greater than equal sign, x cannot be equals to -3.
X cannot be in here. It cannot be strictly greater than -3 or strictly less than +2. So it can be equal to -3 and it can be equal to -2, but it can also be less than this or more than that. So that's how this was written. When you can be equal, you write the square brackets. When you cannot be equal, you write the open parenthesis. Last case, 2 minus 7x over 4 plus 5x greater than -1. Again, by the zero factor property, you need to bring everyone to one side. I should probably say that. That's not terribly obvious, because some people, if they see this with an equal sign, they would multiply both sides by that, but when it comes to an inequality, that's actually a very bad idea. So let's make sure I make a statement of that. Bring everything to one side. Do not clear denominators, in other words. I don't want you to like multiply both sides by LC or something like that. With inequalities, that's very bad. Do not clear denominators. If there is an inequality. Because knowing what the denominator is doing is actually going to be very important, and it will make your solution very different. Now, if it's an equal sign, you know the denominator can't be 0. You don't care about what those numbers are in the first place. However, when there's an inequality, when your denominator is approaching 0, it might change sign on either side, and the inequality sign would flip, and so you have to be very careful. Don't clear denominators when you have inequalities. Bring everything to one side and combine. So what you would do here is you would combine these fractions. So 1 is just 4 plus 5x divided by itself, so it's going to be 2 minus 7x plus 4 plus 5x all over 4 plus 5x greater than 0. Combining like terms, you would get 6 minus 2x over 4 plus 5x greater than 0. Now, here's what you want to do. You're going to set both numerator and denominator equal to 0. Solve for the numbers to test. So this is another way in which a solving strategy might differ from equations. You have to maintain the denominator when you're solving an inequality. It's very important. So here we would have 6 minus 2x, set that equal to 0. And then you'd have 4 plus 5x, set that equal to 0. Now, this would give us what? X would be 3. And this would give us what? X is equal to minus 4 over 5. Now, why it's important for you to know, keep the denominator, you need to remember actually that x cannot be minus 4 over 5. This must be avoided at all costs. You cannot divide by 0. You need to know what that location is. If you just cleared the denominators, you might have lost that information. You need to know it here. So what you would do is now you go and plot these on a number line, minus 4 over 5. Now I know that I definitely cannot be there. There will always definitely be a hole there if it's something that makes the denominator 0. In this particular case, I am not allowed to be equal to either, so the other one happens to be an open circle. So I would plot 3, and that's also an open circle, and in this case, because you have a strict inequality. This to avoid division by 0. And now, as before, we're going to test the intervals. This is negative and positive, so 0 is a number that's between both of them. 4 would be a number over here, and minus 1 would be a number over here. So now I'm going to plug those into this. Now if I plug in minus 1 here, that gives me a positive on the top. Plug in minus 1 here, that actually gives me a negative on the bottom. So overall that's a negative. If I plug in 0 on the top, it gives me a positive on the top. Plug in 0 on the bottom, it gives me a positive on the bottom. So that's a positive sign here. Go over to 4, plug in 4 on top, we'll get a negative. Plug in 4 on the bottom, I would get a positive. So overall that's a negative. Now clearly I want the positive section, so the answer is going to be strictly between these. And so that means your solution is, you can be between minus 4 or 5 and here is a pro tip. If you are very good at graphing and you want to avoid these little annoying calculations, graphs can help. Okay. So let's say I had this guy, x squared plus x minus 6 greater than or equal to 0. We already saw this, that it factored into x plus 3, x minus 2. So we know that x is equal to minus 3, x is equal to 2. Right? So there's actually a way that you could see that the ends would have to be the solution as opposed to the middle, and that's because you know what the graph of this guy looks like. Now if you imagine what this guy looks like, if you look at his graph, what would it look like? Well, it's going to be a parabola, right? Passing through like that. Notice here is where the minus 3 would be, here is where the 2 would be. Clearly the outsides, the left and the right side, are the parts that are above. And so you know that once you see the picture, you know, oh, it's the middle part that's going to be under the x-axis. You know the middle part is what you have to avoid. You don't have to do these testing or the intervals, you just automatically know. Okay, it's definitely going to be minus infinity up to minus 3 inclusive union 2 to infinity, because you know you should get the left and right side as opposed to in the middle. So that way it requires no calculation, you just saw the picture, okay, to be positive it has to be on the outsides. Whereas if you had the sign turned around, x squared plus x minus 6 is less than 0, you would know, oh, well, the graph is going to look like this, so the middle, so the graph is going to look like this. I turn around the graph instead of inequality. So the middle is what I want this time because I want it to be less than 0. So in this case, the answer would be between minus 3 and 2, as opposed to the ends. So a lot of times, just looking at the graph, you can also know the answer. But if the graph is very complicated like this, I wouldn't want to have to graph that. Just plot the answers on a number line and plug in numbers in between them to see where this thing is greater than 0. Okay. That's inequalities. I want to show you guys one more thing and then we'll take a break. I know we're doing familiar material, but still, when you just have a lot of information, brain starts shutting down. Overload, danger will Robinson. The next thing I want to show you is actually, did you guys get calculators yet? Okay, well, I actually want to show you how to use a calculator. So, So like I said, you will be required to use a calculator and solve things by hand in this class. So every now and then I have to show you how to actually do something with a calculator. And since we just talked about solving equations, I want to show you how to actually do that on the calculator.
What calculator do you need again?
You need the
TI-89.
TI-89 or the TI-92, and my tutorials will be based on the TI-89. So, and I normally would put the instructions about what to put on the calculator in the handout that's on Blackboard. So right now I want to show you. There's a lot. Okay. Now I'm going to show you how to actually solve an equation on the calculator. Set the mood here. Okay, so if you printed out the handout, you can follow along with the instructions here. Right now I'm going to teach you how to use the solve command to solve an equation. And what we have here is the home screen of what your TI-89 would look like. And so you can get to this screen if you're somewhere else by pressing the home button. Okay? So this is called a home screen. It will usually remember the last few computations you did unless you clear your memory, but that won't matter. You will enter what you want to in this line, and then when you press enter, the computation will show up in the upper line. So now I specifically want to show you this calculator can do a lot more than you could imagine probably. And I'm going to show you specifically how this calculator can help you solve equations. So this is called using the solve command, and that solve command actually lives in the set of F2 operations. So you'll see F1 is tools, F2 is algebra, F3 is calculations, F4 is other, and so on and so forth. F6 is cleanup in case you want to clear any saved variables or clear any charts or anything like that. But I'm going to show you how to use something here, the algebra section, which will have a lot of different computations. So let's actually look at that. So the solve command works in the following way. You would have to go to F2. Okay. Now you'll see a bunch of things here. It can factor for you. It can do all sorts of things for you. In fact, let's look at factor. We looked at factoring first. So you can actually enter factor, and you can actually enter something that you wanted to factor. Let's say you want to enter this. Okay. In the calculator section, you're brain dead. You forgot how to factor that. Your calculator can actually do that for you. You would simply enter x. Here's your x, y, z here. You can also achieve other letters by using the alpha key, but here we have x squared plus, what did I have there, 5x plus 6? 5x plus 6, close parentheses. So you're telling it to factor that, and ready to go, you factor it for you. So you have very factor things for you. Now let's say you wanted to solve the equation. This was using the solve command. So you can go to F2, and solve would be the first option. Now the solve command has one extra step. You would first enter the equation that you want to solve. Okay? So let's say I wanted to solve this equals 0, which we already found the solution for. I would enter that equation, x squared plus 5x plus 6 equals, there's your equal sign right there, 0. Okay? So you enter the equation that you want to solve, and it doesn't matter what form, even if the 5x was on the other side, you could enter equals minus 5x. Just write it down exactly as it appears on paper right here. Now the next step is a small but significant one. You put comma, and then you put x, and you close parenthesis. Now what that does is it's telling your calculator which variable you want to solve for. Because this calculator can work with multiple variables all at once, you might have like 3 guys, X, Y, and Z's here, and you want to specifically solve for the Y, or specifically solve for the Z, or whatever. So you need to tell it what variable you want to solve for. So this is built into the command. You enter an equation, comma, you tell it what variable you want it to solve for, because you might have several, right? In this class, we won't have several, but that part of the command is important for that reason. So you enter the equation, comma, solve for X. Then enter. And now it tells you your X can be -2 or your X can be -3. And all the equations that we've done before, no matter how complicated, even ones that you can solve by hand, you can solve them on your calculator in this way by using the solve command. And you should play around with the calculator. Like if you go into F2, you'll see all sorts of things, factor, expand. You can even expand stuff. Let's look at what expanding would do. Let's say you wanted to expand X plus 2 times X plus 3. You could do that as well. You could find the zeros of something. So that's if you want to, and that literally takes whatever expression you put into it, it sets it equal to 0, and it does the 0 factor property by itself and tells you what all the answers are. You can approximate things. So for example, if you get an answer in a fraction or something like that, you can use that to turn it into a decimal. There's another trick as well. Your calculator likes using fractions. So maybe let's try solving something else where I can. So let's say you had 2x plus 3 equal 0, and you wanted to solve for x. It will give you -3/2. It tends to always give you like the fraction answer. Now, if you want to have the decimal answer, there are a couple options. You can either use that approximation value, the approximation function, so you can go F2, approximate, and then you can tell it you want to approximate the answer, which is second function, the answer. And it will give you the decimal form. Another way you can do it, which is probably easier, is to use the diamond button. So let's say you want to solve that, F2, solve 2x plus 3 equals 0, comma, x. But you know ahead of time that you want the decimal answer, you don't want it to give you the fraction answer. Then before pressing enter, press the diamond button. So you can go diamond, enter, and it will give you the decimal instead. Okay? So it will tend to want to give you fractions and exact answers, but if there's a case that you don't want it, you can either use the approximation, which is kind of the harder method, or simply press the diamond button before pressing equal, and it will always give you the decimal version of the answer. But otherwise, it's going to give you the fraction if the fraction exists. Okay, we finished chapter 0. These are the skills that we will be using throughout the semester to do all sorts of things. We're going to take a break here. Take about 15 minutes. So return around 11:30, and we'll start with the actual syllabus. Yeah, we're going to start 1.1.